Why is the sky blue? Why does the sun turn red at sunset? Why do stars twinkle, but planets don't? And how does a rainbow appear? Every one of these is the same physics, light bending and scattering in the air, and it all starts with a simple glass prism. By the end, you'll explain the sky like a physicist. Let's start with the prism. A prism is a triangular block of glass. When light passes through it, it refracts twice, once entering, once leaving, and both bends tip the ray toward the thick base of the prism. The total turning of the ray from its original path is called the angle of deviation. So far, it's just refraction, the bending we already know, but a prism does something extra and beautiful. Send white light through the prism and it fans out into a band of 7 colors: violet, indigo, blue, green, yellow, orange, red. This splitting is called dispersion, and the band is a spectrum. Why does it split? Because white light is a mixture, and the glass bends each color by a different amount. Violet bends the most, red bends the least, so they separate. Remember it as VIBGYOR. Here's the proof that white light is genuinely a mixture. Take a second identical prism and place it upside down after the first. The first prism splits the colors. The second bends them back together, and out comes white light again. Isaac Newton did exactly this. Split, then recombine. The white is restored. A rainbow is nature's prism show. After rain, the air is full of tiny water droplets, and each droplet acts like a little prism. Sunlight enters a droplet and reflects once off the inside-back surface, then refracts again on the way out, and during all that bending, it disperses into colors. Millions of droplets together paint the arc, always with the sun behind you. Now leave the prism and look at the air itself. The atmosphere isn't uniform. It's denser low down and thinner high up, so its refractive index changes gradually with height. That means light passing through the air bends continuously, not in one sharp turn. This is atmospheric refraction, and it explains 2 everyday sights. First, the twinkling of stars. A star is so far away, it's effectively a point of light. As its rays pass through the ever-shifting layers of air, they bend by slightly different amounts moment to moment, so the star's apparent position and brightness keep flickering. That's twinkling. Planets, being much closer, look like small disks, not points. Their many points of light average out, so planets don't twinkle. Second, the sun appears about 2 minutes before it actually rises, and lingers about 2 minutes after it sets. Atmospheric refraction bends the sun's light over the horizon, so we see it while it's still geometrically below the horizon. The same bending slightly flattens the sun's disk at sunrise and sunset. Last piece, scattering. When light hits very small particles, air molecules, dust, tiny droplets, it bounces off in all directions. That's scattering, and when it makes a beam's path visible, like sunlight streaming through a dusty room, it's called the Tyndall effect. The key rule: tiny particles scatter shorter wavelengths, the blue end, much more strongly than the longer red end. Now we can answer the big questions. The sky is blue because air molecules scatter blue light far more than red, so blue light bounces around the whole sky and into your eyes from every direction. And at sunrise and sunset, the sun's light travels a long, slanting path through the air. So much of the blue is scattered away before it reaches you, leaving mostly red and orange. Same scattering, 2 colors depending on the path length. By the way, that's also why danger signals are red. Red scatters least, so it travels farthest through fog. Your turn. The question's on screen. Pause if you like, but try it first. 10 seconds, go. The sky is blue because air molecules scatter shorter wavelengths much more than longer ones, and blue is at the short wavelength end. So blue light is scattered the most and fills the sky. The answer is, blue light is scattered the most, option A. And that completes the human eye and the colorful world. The eye, its defects, the prism, dispersion, and why the sky and sun wear the colors they do. Free notes with practice questions are in the description. Subscribe for the next chapter, Electricity. This is Clarix. Keep going.